big
you this
conspiracy.
Yeah,
already,
but that's
so-
okay. It's when you're being arrogant when it
Yeah,
becomes
when
a
you feel the
problem.
authority. That's it.
Right, but I have
That's
one
when
more
it becomes a
practical
problem.
way.
When you become arrogant and you talk down to people, that's when it becomes a problem. It's okay saying, yes, this is what I learned and what I was taught, and you're being humble about it, but he's not. He's being very arrogant, so he has to be humbled. He needs to be
Well,
brought
yeah.
back
Well,
down to earth.
I was going to try to humble him. I don't want to get Bitcoin lost though, because he was trying to speak. I was going to try to humble him on the airplane issue, because the airplane wouldn't even be able to land if they were treating the Earth as stationary. If it's actually moving, that's just a practical thing that you can common sense deduce. How could it be? How could the pilots all be trained to treat the Earth as stationary if it's actually moving? It makes no sense.
Newton's laws, it makes perfect sense.
No, it doesn't.
Yeah, but
You just-
Newton's
you-
laws,
wait,
you're
earlier
just
you
going
said-
off based of
Hold on.
words.
Hold on,
You're
let
not
me just go
showing
back and forth with him
any
on this
evidence.
since I started it. You earlier said that you understand the difference between the kinematic concept and the dynamic physics, right? Like the
I
kinematic
didn't hear
concept
you.
doesn't substitute. The kinematic concept can't substitute for the dynamic reality, right?
I don't know what you're saying.
Well, kinematics could be just mathematics, and a mathematical explanation for what's happening or what the observation is. And you can write in rules with kinematics, and it just cancels things out and makes it all work out mathematically. But it doesn't really explain the dynamics, which is the physics of it all.
Yeah, that's
and
what the gravity and the Kepler's equations are. They explain it all perfectly.
Well, actually, there's a problem with Kepler's. Let's not get into that. But
It's just so
as far
crazy
as the
to
planes
hear.
go, there's one practical thing I want you to explain to me.
It's so crazy
If a
to hear
plane-
Globers like come in with some kind of narrative, like
Well,
with
anyway,
science.
well, of course they're
and,
going to have
like,
a narrative. Hold on a second.
Oh my God.
let me just continue this real quick with Hap. Hap, when a plane travels and it has only a 500 mile per hour conserved momentum from the latitude it takes off, when it travels to the equator to land in a city that's on the equator on a runway where it's moving 1,000 miles an hour, and you only had 500 miles per hour conserved momentum, how do you explain that the pilot is in perfect sync with the rotation of the Earth eastward tangentially, so that it could treat the Earth as stationary, just as pilots are taught to when it goes to land? How do you explain that?
I guess I don't see the issue with it. So you take
Well,
off
it'd be 500
with
miles per hour faster at the destination that it's going to on the equator, right?
right.
It's moving at 1,000 miles on the equator, but it only had 500 miles per hour conserved momentum. when it
Yeah, I
started.
understand the question. Okay, so
So how does the
So-
pilot catch up to be at the same exact sync as the 1,000 miles an hour eastward tangentially sideways
how-
that's landing
how
on a
long does
north-facing
that
runway south?
flight take? Is that about a 6-hour flight?
Okay, yeah, but what is it? Adds up to 500. Even if you want to make it that, and this is what
So
usually
make it
Globers
a
go to,
5-hour flight.
incrementally
Right,
over
it's incremental,
time, even
bit
if
by
that.
bit.
Okay, yeah, so incremental. So are you saying that the pilots are taught to incrementally catch up?
The pilots are meant to follow or the autopilot, a certain heading and what? Azimuth, whatever. A certain heading at a certain altitude, and that's what the plane does. And if it has to incrementally give it a little budge east or west or whatever every 5 minutes, it does so.
Okay,
No
so
problem.
let's just take autopilots off the table for now, because we know that
Sure.
pilots were always flying before the autopilot idea even came along. So you're saying that if it's just a plane that's flying towards the equator and the autopilot doesn't do it, would the pilot then have to be trained to compensate for that?
Yeah, he'd be following his compass, and if wind directions threw him off, or this Earth orbit stuff threw him off, he'd correct to continue following the compass heading.
All right, so the
Be
next thing we
very
need to do is
small and
make sure.
incremental.
Yeah, you also have to make sure that, first of all, there's a difference between the winds affecting the plane and the ground moving separately from the plane, right?
How so?
Now you've admitted,
so?
well, because you've admitted that the pilot would have to correct, right? Meaning that
But
he's not
why is there a
automatically in
difference
sync with the Earth.
between winds changing where you are on the ground and the ground moving, changing where you
Because-
are above
Well,
the
I'm about to get
ground?
to that. Because when he goes to land, right, he's got to treat the Earth as perfectly stationary. That means he'd have to be accelerating at the exact same rate as the Earth without any notice of any change between the plane's eastward tangential velocity and the Earth's tangential velocity. It'd have to be perfect. It would have to be so
No.
in sync that there would be no notice of any kind of movement of that runway he's landing on, right?
No, because the atmosphere is rotating with the Earth. And if you have ever watched airplanes land in a crosswind, you'll see that
Right.
there's
Wait,
a
hold on.
huge amount
I'm
of
getting there.
change from the crosswinds that are far greater than, you
Just
know, whatever you're
wait,
talking
No,
about
hold on,
with
wait,
the
wait.
Earth.
This is the point though. The crosswinds, dealing with crosswinds as you land on a stationary surface is one thing. Dealing with crosswinds and trying to land on a surface that is moving eastward tangentially at a given rate is another thing. You can't conflate crosswinds with the Earth moving eastward consistently. That means the
since
plane
the
would have to be
atmosphere-
moving eastward. Can you at least agree
Since,
that the plane would
since
have
the-
to be moving eastward? Hold on, wait. Can you agree that the plane would have to be moving perfectly eastward with the runway as it's landing so that it can treat the Earth as stationary? It has to be moving with the Earth, moving in tangential sync
He
with
doesn't
the Earth,
understand
1,000 miles an
what's
hour.
going on. Like you really.
No, it has to go
he doesn't-
south. It
he
has to go
does not
sideways if it's
understand.
facing south. It has to be in perfect sync with the Earth. You don't understand. If it has to accelerate an extra 500 miles per hour, it has to continue accelerating eastward tangentially with the Earth as it's slowing down to land in the opposite direction or in a perpendicular direction.
The atmosphere
to-
is moving with the Earth. The airplane is in the atmosphere.
So you're saying the atmosphere
there-
pushes the plane like a wind? It accelerates the plane automatically? Is that what you're saying? The atmosphere pushes the plane in perfect sync with the Earth? Because before you were saying
If there
that
is
the
a
plane needs to make
wind,
corrections. Are you
If
saying the
there
plane
is-
needs to make corrections, or are you saying that the
11,000
atmosphere does it
miles
for
per
it?
hour, right? 11,000
What's the
miles
difference?
per hour.
Wait, hold on. Hold on. This is a point. You were saying earlier that you have to make incremental corrections. But if the atmosphere is pushing the plane automatically in sync with the Earth, then what does it need to make corrections for?
for how the atmosphere is moving the plane. Jesus.
No, that's for winds. That's for crosswinds. You can't conflate atmosphere pushing the plane with winds
Well,
pushing the plane in all directions. The winds
how
push the
far
plane in
is-
all
Sure I can.
directions.
Because they're the same thing.
What
We're
is
not.
what
Yeah,
This is
they
a
are.
big point. They're not.
okay?
And
I'm
besides,
the
even
neutral
if,
party here.
hold on, wait. No, wait, hold on. Just let me
So
just finish this
what
point
are
because you won't be able to
you
answer
and
this.
what are you claiming that the Earth is traveling?
Wait, I'm not complaining
miles
about
per
anything.
hour?
Let me just say this. If this is another scenario that ruins it all for you.
Because
If you
it's
think
about
if
11,000.
you think that the pilot's correcting eastward, right, to catch up, then he should be trained to. Now, if it's the atmosphere pushing the plane eastward, that means there have to be a wind because there's no difference between a wind atmosphere and a wind that goes in all directions. So it has to be a perfect wind accelerating the plane. Otherwise, you have no mechanism to push the plane sideways. And now
He
if it goes
doesn't know
west
shit.
southwest, wait, hold on. If it goes west southwest, right, it's not going to be able to deviate east. There's no way to correct east if it goes only west southwest towards the equator.
Yeah, he doesn't know shit.
So you wouldn't be able to deviate east to catch up with the Earth. And even if you were to catch up to the Earth, you'd have to keep accelerating that extra amount that didn't match your original conserved momentum as you're trying to slow down to land in a perpendicular direction. And that means the plane would be moving 500 miles per hour sideways as it's slowing down to 0 miles per hour headed south on a runway north or whatever angle the runway happens to be. The calculations are ridiculous. It would never work that way. The only way
Yeah,
a pilot can treat the
you're
Earth
right.
as
It would never
stationary
work.
is if it's stationary.
On a rotating Earth, you're right, the math wouldn't work the way you think it does. It works just fine on a rotating Earth because the atmosphere is moving with the Earth. You don't need to do any.
But you cannot validate.
500
hold on.
miles
This
per
is
hour.
wait.
This
This
is the opposite
is
thing.
my last point. This is my last point. This is why I brought up kinematics to begin with. You can have a kinematic rule that says the atmosphere makes the plane automatically in sync with the Earth. And without calling it a wind, without having to identify the force or how fast the wind blew to make sure that the plane was in, without having to worry about saying he makes corrections, and then it has to do with the atmosphere, but not the rotating Earth. If the Earth is moving independently of the plane, which you agreed to because of the corrections, then it would have to be in perfect sync and it'd have to match that tangential velocity in a cognitive way. You can't just tell the pilot to treat it as perfectly stationary if it's actually moving. And if he went west southwest, he would never be able to correct east. There would be The wind would have to be blowing him backwards faster than he's going forwards. And by the time he goes to land on the runway, it would have to continue accelerating him eastward in perfect sync so he could just treat the Earth as stationary when he goes in the opposite direction down to 0 miles per hour, and he's going 500 miles per hour or 1,000 miles per hour sideways. That's ridiculous. It never would work. You can't conflate
Guys,
the two.
it's pseudoscience anyway because you can't repeat it.
I'm actually
you cannot
not
test what he's
understanding
saying.
what you're saying right
Listen.
now
To
because
avoid
of
all this
gravity.
nonsense, right? Science itself tells you you cannot test what he's saying. It cannot be recreated. It is pseudoscience, and it's just a theoretical theory. That's
Pseudoscience.
it. It's not based in no
Pseudoscience.
science whatsoever.
Wait,
I don't even know
My
what you guys
point is
argue
that you
these guys
can
when they
test
push
What the
these
fuck is
theoretical.
pseudoscience? What are you saying?
Wait,
This
Explain
you can
Bitcoin
test
guy
that
is
because
Explain that.
planes
Explain that to
planes
everybody
fly and
else.
land
Like,
all the
what
time.
is pseudoscience? What
nobody cares what
pseudoscience? What is that?
Nobody cares about arguing what pseudoscience is. But
Oh, nobody cares
what
about pseudoscience? What?
Hey, Hap,
What?
if you're going an opposite,
This guy's just trolling. This Bitcoin guy is not helping the conversation
Yeah,
whatsoever.
hang on. Can I answer Bitcoin's question? Maybe not about pseudoscience, but the fact that you said this is not repeatable, right? This is the difference between our definition of a scientific method being applied versus what even the skeptics, middle ground, or the globe heads, right, are believing. Do you see how New Perspective just laid out?
Did you say believing?
Can you just let me finish real quick? I think
You said believing.
Okay, not believing, but
I heard you say it.
okay.
he
What
did.
does that
Hold on,
mean?
don't troll him while he's talking to
Believing.
Hap. Don't troll him. Come on, don't worry about the
It's fine.
one word he said.
It's fine. Let me
He's trolling.
just explain it again. Maybe without iterating terms that might prove my point wrong. Okay, but here, let me put it in simple terms. New Perspective just laid out an observable, repeatable experiment, and you cannot validate that. Like
What observable experiment?
Flights. If
Landing a plane on a moving surface when the pilot's not taught to treat it like anything but a stationary surface. If the Earth were moving, which it's moving independently of the plane, the pilot would be made aware of that because they would overtrain their pilots. They wouldn't say, "Don't worry about it. It's just the same." I mean, Hap, let me ask you: would the training? What would be the difference? This is an honest question. What would be the training? What would be the difference between training a pilot to fly and land on a stationary surface as opposed to a spinning ball surface? What would be the difference between training one pilot versus another?
Based on the scale.
I can't think for
Let
myself.
him answer.
Hey, Bitcoin, you interrupt again. I'm taking your mic. New Perspective and Hap, y'all finish this up. I like the build. Hap, think very carefully about what you're about to say, and then we're going to get to the hands and then rotate some mics. Bitcoin, don't interrupt. If you want to say something, raise your hand, please. Thanks.
New Perspective, based upon the scale of the Earth and the rate at which it's rotating, there'd be no difference in training or landing on a spinning ball or not. You're very confused about flight and atmospheres and rotations and 1,000 miles an hour at the equator and taking off from 500 miles an hour.
Wait,
area of the Earth.
At the beginning, you said there would be corrections, that the pilot would correct eastward for the extra, or the autopilot would do it. If autopilot doesn't do it, the pilot has to do it to catch up with the Earth, right? To have that extra 500 miles per hour eastward tangential velocity. The pilot would have to be aware of that. You're saying there'd be no difference between training somebody to land and fly in a stationary level Earth as opposed to a spinning ball Earth? You don't think there'd be any dynamical difference at all? That proves my point right there.
Yeah, I'd say there's no difference. I mean, you just keep the heading, and if there is a Coriolis effect or whatever, the autopilot will take it into account, or the pilot following the compass heading will take it into account. There'd be no difference in training. You're flying due south.
If there's no difference, he'd never have to take anything into account. Why are you saying the autopilot or the pilot would take it into account?
Yeah.
Yeah, so there's nothing to take into account if it's exactly the same.
Your level of confusion is too
No,
much
it's not a
for me to deal
confusion.
with.
It's an honest question you have no answer for. You're saying you would take it
I
into
said my
account, or the
answer is
autopilot would do
you
it. But
maintain
then
the
if
same
it's no
heading.
different than being a stationary Earth, there would be nothing to take into account.
Correct. You would maintain heading, and whether the Earth is rotating under you or there are different wind speeds at different altitudes, just maintain the same heading. No training differences required.
That would be ridiculous to begin with, because there'd be so many dynamical differences, including the fact that your city that you're headed towards is moving 5 miles per hour faster than when you started off. You think that wouldn't take a correction? You don't think that would
Nope.
take some jets on the side of the plane when it's trying to land to a stop? It'd have to be moving with the Earth
Well,
at the
once-
exact same
once
tangential
it's-
velocity.
once
You don't
it's
get
a-
that? It's just a
That makes
basic
sense.
observation of
Once it's
reality that
already-
you are not acknowledging.
Once it's already at its landing spot, it is stationary with respect to the Earth under it, because it's in the atmosphere, which is moving with the Earth. It's not like they take off where it's 500 miles an hour, and when they get to the equator, everything's traveling 500 miles an hour faster.
Well, that's what your model
It
says.
stays in the atmosphere. No, the atmosphere moves with the Earth.
Well, how come? Okay,
Yeah, but you
okay,
can't say
time
the
out, time out.
atmosphere
Okay,
moves the
time out,
plane without the
time out, time out.
mechanism. You have no mechanism. The atmosphere doesn't move the
What
plane
if you're
without it
moving in
being
the
a
Does a
wind.
opposite
wind,
direction?
does
What
a
if you're moving
No,
in
wind
the
wind's
move
going
an
all directions,
airplane?
brother.
What if you're
Wind's
So if
going all
the
directions.
atmosphere is
There's
moving,
not a
it moves it.
Oh my goodness, y'all. All right. This is what we're gonna do, because I think other people do want to chime in. I do like this build. I'm gonna let Hap just respond really quickly. New perspective, give you a last thought, and then we'll go through the hands. And then after that, we could double back to this conversation in a little bit. I think Hap was actually trying to leave a little while ago. So shout out to him for kind of sticking through this. But go ahead, Hap. Reply to what he said. I'm gonna give new perspective the last word, and then we're gonna move through the hands. And if you want to stick around to continue that, Hap, you could, and we'll double back. But I just want to make sure that the hands are acknowledged.
Sacred, my gratitude for you maintaining a wonderful space and keeping everybody polite and everything. I gotta go. Good to talk to you all.
All
Fairly
right,
well.
before you go, Hap, I just want to make sure you know that the kinematic rule that the atmosphere makes the plane automatically in sync with the Earth is just a kinematic rule that you have to think about it like just a concept. You have to have a dynamic, actual situation going on where the plane is moved by a mechanism. You can't just say atmosphere without it being a wind. The wind's moving in all directions, so it doesn't work, brother.
Yo,
Well,
can I just
if
ask one
the
question?
atmosphere is moving, it's like a wind.
Okay,
Anyway,
what about
Like a
fare
going
thee
the
wind,
well,
opposite
but not a
all.
wind.
What about when you're going the opposite direction?
That's the dynamic reality
That's what I'm
that
asking,
you're
like a
denying.
simple question. When you're going the opposite direction.